Hello and welcome. This is Alon Sela, and today we are going to talk about the sample space. So, without further ado, let's get going with it. So, in this lecture, we are going to talk about three main things. We're going to start by talking about what is a sample space. We'll see a couple of examples. Then we're going to define what is an elementary outcome, and then we're going to talk about the types of sample space. I hope you will enjoy it. Let's get started. So, what is a sample space? Let's talk about let's take an example of 52 cards in a deck of cards, and we're going to ask the question, what is the color of the card that we are randomly choosing? So in this case, because there are only two colors, red and black, we have only two outcomes. Therefore, the sample space, which we denoted it by omega, is the set of two outcomes, black and red. So in this sample space we have two outcomes, black and red. Now let's see another example of another sample space. So let's talk again about the same deck of cards with 52 cards in it, but now we're going to ask a different question. Now we're going to ask, what is the shape on the card that we are randomly choosing? In this case we have 1, 2, 3, 4 possible outcomes. Therefore, the sample space will be the set of we have spade, we have diamond, we have clubs, and we have hearts. So in this case the possibilities are 4, and the sample space is the set of these 4 outcomes. Let's see another example. Let's say we have the same deck of cards, but now we can ask the question, what is the number on the card? As you might know, there are 13 possibilities: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and let's say that the prince is 11, the queen is 12, and the king is 13. So in this case we have 13 outcomes, and therefore our sample space will be this set of 13 outcomes: 9, 10, 11, 12, and 13. So what we seen so far, we've saw that we have a deck of cards with 52 cards in it. We are randomly selecting one card from the same deck, but we have different sample spaces, and this is because each time we ask a different question. So the sample space omega depends on the question or the experiment that we want to check, which bring us to the next topic of elementary outcome. So let's recall the sample space in which we had only two outcomes, black and red. We say that we are calling elementary outcome and denoting it by small omega. Okay, small omega is an elementary outcome. Is elementary outcome, and in this case we have omega 1 and omega 2. Omega 1, small omega 1 is black, and small omega 2 is red. We have two outcomes for this sample space. Now let's consider the second sample space that we saw, in which we have diamonds, club, heart, and spade. So we have four elementary outcomes. Diamonds was the first outcome, clubs was the second outcome, heart was the third outcome, and spade was the fourth outcome. So in this case we have four elementary outcomes, and just to let you know that the elementary outcome of an experiment can be basically anything that can be possible in as an outcome can be in our sample space. Let's say for example, let's take this sample space. So you can think about maybe a keyboard and a child accidentally playing or touching the buttons, and only four of them works. So what we can talk about, what is the probability that one of these notes will be chosen at randomly. Okay, so in this case the sample space is made of four elementary outcomes. It's not numbers, it's not words, it's not colors, it's symbols. Okay, so we have four elementary outcomes. So our last topic for today is the types of sample spaces that we have, and we have three types of sample spaces. Okay, we have a finite sample space, we have countably infinite sample space, and we have uncountably infinite sample space. So let's see some examples. Finite sample space is basically, I believe everyone saw something like this. We can think about the examples we just saw, or let's take a new example in which the sample space is the number that can come out in an experiment of rolling a die. So we have 1, 2, 3, 4, 5, and 6. So this is an example for finite sample space. Now let's take an example for countably infinite sample space. In this case we can take, for example, omega to be the set of all natural numbers. In this case omega will be 1, 2, 3, 4, and so on and so on. So it's infinite sample space, but because we can count it, we call it countably infinite sample space. And for the last type of sample space, we can take, for example, to a sample space we can take R, which is all the real numbers. It is too big of a set, and therefore we cannot count it, and therefore it's an uncountable infinite set. And these are our three types of sample spaces. So this conclude our lecture for now. I hope you enjoyed, and I hope to see you next time. Until then, I am Alon Sela, and I hope you enjoy the world of probability. See you in the next one.